Black holes are already rude enough. They bend light. They eat stars. They turn physics into a stressed group project. But the annoying thing is this: they look like an ending, and endings make humans suspicious. If something falls into a black hole, where does it go? Does it get destroyed? Does it disappear from the universe? Or is the black hole less like a trash can and more like a door with terrible customer service? So here is the dangerous question. What if black holes are not just cosmic graves, but doors to somewhere else? Start with the part we actually know. A black hole is not a hole like a hole in your sock. It is a region where gravity is so strong that past a certain boundary, nothing can escape. Not a rocket, not a signal, not light. That boundary is called the event horizon. It is where the universe says, after this, no updates. From far away, a black hole can look like a dark object surrounded by glowing material. But the event horizon is not a surface you bump into. It is more like a one-way rule. Cross it, and every possible path points inward. Very dramatic. Terrible for tourism. This is why black holes feel like doors. Doors have two sides. You go in, something happens, and maybe you come out somewhere else. But an event horizon is sneakier. From the outside, it acts like a door that only opens inward. You can enter. You cannot send a postcard back. Because no information escapes easily from inside, imagination gets too much free time. Maybe there is another universe. Maybe there is a tunnel. Maybe there is a cosmic basement where all missing socks finally meet. The honest answer is, we do not know. The fun answer is, the math gets weird very quickly. At the center of the classic black hole picture is something called a singularity. That word sounds like an expensive problem, and it is. It is where our equations say density becomes extreme, and space-time curvature becomes infinite. But when physics says infinite, it often means our theory is waving a flag and asking for help. General relativity is great at gravity. Quantum mechanics is great at tiny things. Inside a black hole, you probably need both. And we do not yet have a complete theory that makes them behave nicely. So the singularity may not be a real physical point. It may be a sign that our map reached the edge and started drawing warning doodles. This is where wormholes enter the chat. A wormhole is a hypothetical shortcut through space-time. Imagine the universe as a sheet of paper. 2 points are far apart across the paper, but if you fold it, they can touch. That is the basic wormhole mood. In some mathematical versions, black hole geometry can look connected to another region. So people ask, maybe a black hole is one mouth of a tunnel. Maybe the other mouth is somewhere far away. Maybe it is in another universe. Fantastic for science fiction. Stressful for actual physics. The kind of wormhole you would want to travel through may need exotic conditions we have never seen. The universe does not hand out shortcuts just because we are impatient. There is also the idea of a white hole. If a black hole lets things enter but not leave, a white hole is the opposite. It sounds like a black hole played backward, which immediately makes it feel like a cosmic magic trick. Some solutions to Einstein's equations allow white hole-like objects on paper, but on paper is doing a lot of work. We have not seen a confirmed white hole in the sky. Making one behave in a stable universe is not simple. Still, the idea is irresistible. What if matter falls into a black hole here and emerges somewhere else? That is the kind of sentence that makes thumbnails wake up. But there is a huge problem. Falling into a black hole is not like walking through an airport tunnel with better stars. Near a black hole, gravity can change dramatically across an object. The closer side can be pulled much harder than the farther side. This stretching effect is often called spaghettification. Yes, physics saw something terrifying and gave it a pasta name. Depending on the black hole, this could happen before or after the horizon. For a small black hole, you are in trouble early. For a supermassive black hole, crossing the horizon might feel strangely normal at first, which is somehow worse. The universe might let you enter the worst place possible without a sound effect. So if black holes are doors, they are not friendly doors. Their welcome mat is made of tidal gravity, and after the horizon, every future direction points deeper in. The doorway metaphor is fun, but the actual object is not a clean portal in space. It is a region where space-time is shaped so severely that go back may stop being an option. That is not just a locked door. That is the building quietly rearranging every hallway inward. Then comes the information paradox. In ordinary quantum physics, information about a system is not supposed to simply vanish. But black holes seem very good at hiding things. If a book falls into a black hole, can its information ever be recovered? Or is the universe allowed to permanently delete it? Physicists do not like permanent delete buttons. They make equations nervous. Hawking radiation made this even stranger. Black holes are not completely black forever. They can slowly radiate energy and, over absurdly long times, shrink. So if a black hole eventually evaporates, what happens to everything that fell in? One possible clue is that black holes may store information on their surface area, not their volume. That already sounds suspicious. It is like discovering your house is secretly described by the paint outside. This idea helped inspire the holographic principle. Very roughly, it suggests information in a volume might be described on a boundary. Do not worry if that sentence feels slippery. It is. But it gives black holes an even stranger flavor. Maybe what falls in is not simply gone. Maybe information is transformed, scrambled, encoded, or preserved in a hidden way. The black hole may be less like a shredder and more like the worst filing system ever. This is why some people like the door idea. If information cannot be destroyed, maybe it goes somewhere. Another region, a baby universe, or radiation so scrambled that decoding it would make your laptop cry. But here is the important part. Somewhere does not have to mean a place you can visit. Information can be preserved without giving you a cute travel brochure. The universe is allowed to be technically fair and emotionally unhelpful. So when someone says black holes are portals, ask, portal for what, matter? Information? Geometry? Or imagination drawing a door on something we cannot see? There are also rotating black holes. Real black holes probably spin. Spinning black hole solutions have strange mathematical features. In idealized versions, the inside can look less like a simple crash and more like a space-time maze. That sounds promising until you remember idealized. Real black holes may be messy. They may contain radiation, infalling matter, instabilities, and quantum effects that ruin the clean map. Physics often says yes, this door exists in the equation, but please do not lean on it. Still, rotating black holes keep the mystery alive. They suggest the inside might be more complicated than a simple dead end. Not safe, not proven, but complicated. Another idea is that black holes might create new universes. This is speculative, but wonderfully strange. Maybe the extreme conditions inside a black hole do not end in a final point. Maybe they bounce. Maybe the collapse becomes the seed of a new expanding region of space-time. From our side, it looks like matter fell into darkness. From another side, perhaps it looks like a beginning. That is not established science, but it makes the word inside feel too small. A black hole may not be a room. It may be a boundary between descriptions. From outside, an object falls in. From another perspective, something else may be happening. Reality loves making simple words embarrassing. So what is actually on the other side of a black hole? The most honest answer is, we do not know. The boring answer is, probably not a convenient tunnel with airport lighting. The exciting answer is space, time, information, and reality may not be built the way our brains expect. Maybe the other side is not a place. Maybe it is a problem. A place belongs on a map. A black hole may be where the map stops acting normal. That is why black holes are so powerful as mysteries. They are not just giant vacuum cleaners. They are where our best theories meet, argue, and leave separately. And here is the funny part. We do not need black holes to be portals for them to be terrifying. Even if nothing comes out somewhere else, they force us to ask whether information can be lost, whether space-time has edges, and whether inside means what we think. The doorway idea might be wrong, the tunnel idea might be wrong, the baby universe idea might be wrong, but the question keeps working because black holes are not just objects. They are nature saying, you do not understand the rules as well as you think, which is rude, but fair. So maybe black holes are doors. Maybe they are locks. Maybe they are cosmic one-way mirrors. Or maybe they are not built for our door metaphors at all. What we know is strange enough, a boundary where light cannot return, time and gravity misbehave, and information becomes one of physics' hardest questions. If that is not a doorway to somewhere else, it is a doorway to a weirder understanding of here, and honestly, that might be better. Because the scariest possibility is not that black holes lead to another universe. It is that they lead to the truth about this one. If you could safely look inside a black hole for 1 second, would you do it?